Hi, and welcome back to Sustainable Teacher. If it is your first time here, my name is Leticia and I'm glad to meet you. And if you've been here before, I'm happy to see you again. In today's video, we are going to talk about forces and stresses, which are something related to our next video about structures, but we will learn about this before to understand better structures in the future. So, if you are interested in this video, please subscribe, hit the notification bell, and if you like this video, give it a thumbs up. So the first question you should make yourself is, what is a force? A force is a magnitude that indicates the ability of doing a physical work, like the capability of doing it. A magnitude indicates both the intensity, so like kind of the quantity of work, and also the direction. The thing is that usually when we apply a force, we can do three things. We can make an object that was motionless, we can make it start moving, like in a car, the engine, when the car is stopped and you start the engine and then the car starts moving. Or we can do the opposite, we can stop an object that is in motion, like when we press the brakes and the car stops. And the third case is when the object can't move and the result is a deformation. Imagine that I have a can of Coke and I start moving it in here. Imagine there is a surface in here and I start moving with my finger, and then when I get to the wall, of course the can go through the wall. So the thing is that I'm gonna crash it in the end, I'm gonna deform it against the wall. It's like when a car has an accident because it crashes against a wall or something, or another car. That's so sad, but it happens. And then the object will suffer a deformation due to that force that has been applied to it. In the case of structures, usually forces are loads. Loads is a weight that the structure should support. And these loads could be static, like this is always the same weight, the same load, like a building on the floor, or they can be dynamic, they can't change, this is not always the same magnitude. It's the case of a bridge, because sometimes there will be only one car passing through the bridge, then sometimes there will be two cars, three cars, 1,000, 3,000, 2,000, I don't know, different kinds, and also different kinds of cars with different number of people inside. So the force is not always the same, it depends on the state of that moment. So this is a dynamic load. And the third type of load is the environmental load. It doesn't come from a specific point, like a building over a floor or a car in a bridge. It's the case of earthquakes or tornadoes, when it is like the earth, somehow the one that is applying that force, that load on the rest of structures. Apart from loads, one of the characteristics of good structures is that they should be balanced. They should not move or crawl or collapse or fall apart if we apply a load, a force. And to do so, there are two ways of doing this. It depends on if the object is still or if the object is moving. In the case of movement, in the case of moving objects, to keep the object moving, we should compensate the inertia. So if we don't compensate that inertia, that friction caused by different things, the car won't move or won't keep moving. The opposite case is in still objects. In this case, what we want to do is to make sure that the object will stay still, won't move. It's the case of a book over a table, and in this case, is the gravity, the one that is doing the work, it's the load that is going to be pushing down our structure. Usually we can divide forces in two main types and two subtypes in each. We can talk about forces according to time or forces according to the way that they are applied. In the case of time, we can talk about fixed, like stable, permanent forces. All that load or that force, that weight is gonna be always there forever, like in a building, over the floor, unless you demolish the building, of course, but usually that's not the case. And the opposite to fixed force on time is variable, like in the case of the bridge. So it's related to the static and dynamic forces. And related to application, we have two subtypes, which are concentrated or distributed. If they are concentrated, it's because we are concentrating all the force, all the load in one point. It could be the case of a hammer and nails. When you use your hammer over a nail, you are concentrating all the force, all that you can do with your hammer on the tip of your nail. And the other way is distributed, when we don't concentrate all the force in only one point, but we distribute it over a surface. It could be a waiter with a tray, it could be a table with 4 legs. There are different examples. And to finish with forces, we should talk about stresses, because when we apply forces or loads to a structure, they will suffer different type of stresses. We can say that there are 5 main types of stresses. I'm going to explain them to you really quickly. The first type of stress is tension. Is when we tear apart something. Is the case of a tent, like the wires that keep a tent tense, the braces on a bridge, all the wires, cables that are used in hanging bridges. The opposite of tension is compression. Is when we push from each side, from every side, something. It could be the case of a table, the case of a column, the case of the floor of a building. Apart from that, we can also have bending, which is also related, and it's when we try to fold something. The stress of that thing is a bending stress. The typical case is a bookshelf with lots of very heavy books. Another case is torsion. Is when we try to turn something, when we turn a wet cloth to make it drier. And finally, we have shearing, which is when we try to apply forces in different directions to an object, like when we are cutting. Or in the case of the earth, a geological fault is when the earth moves due to an earthquake or any other reason in different directions, and it divides, it splits in different directions. This is a geological fault. And that's it for today. I hope that now you understand better what is a force, what is a load, and how to classify force, and also the stresses that can be caused in structures due to that forces or that loads. Leave in the comments if you knew something about this before, if you ever thought about relating structures with forces, or maybe you've learned about force in physics and you've never thought that it has nothing to do with structures or building structure or technological structures. Everything you want to say, please leave it in the comments, and of course, see you soon!